Okay, guys, welcome. Today we're going to talk about transformations of trigonometric functions, and specifically we'll talk about how to find the amplitude of a function, trig function. Specifically, we'll talk about how to find the period of a trigonometric function. We'll talk about how to look at a phase shift, and we'll talk about how we can sort of account for different types of transformations that will adjust the amplitude, period, and phase shift of a trig function. Okay, so first we're going to start with sort of a motivating example. Okay, so we're going to look at sketching the graphs of just regular cosine and then 3 times the cosine of x on the interval -4 pi to 4 pi. Okay, so let's just get a graph on here. And we'll make this nice and large so we can sort of see what's going on. So let's make this be 2 pi. We'll make this be pi, and then we'll make these the angles in between them. 3 pi over 2. Okay, and then we want to take this out to 4 pi this direction. So then we'll have halfway between that a 3 pi, and then here we'll have a 5 pi over 2. And here we'll have 7 pi over 2. Okay, then we need to do something similar on the other side. So here I would want a, oops, so -2 pi and a -4 pi. And let's see, so then halfway between that, need a -3 pi, -5 pi over 2, -7 pi over 2. Here we have minus pi over 2, -3 pi over 2. Okay, so I actually think I'm going to copy this graph so that I can reuse it later on in this video. So let's grab this. Let's try that again. Okay, so let's copy it so I can use it again when it comes up. Okay, now we want to first graph the cosine graph. All right, now we know that cosine is bounded between 1 and -1, right? And I'm sort of going to cheat here. I know what's going to come in the second part of this. So let me put those on there. But if we graph cosine, we know that at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine is -1. 3 pi over 2, we're back at 0. And at 2 pi, we're at a height of 1. All right. And then, of course, at that point, it repeats. So it goes back to 0 here. It goes back to -1 here. Back to 0, and back to 1. All right, so this left side, or sorry, this right side of the graph will look something like this. All right. Okay. All right, so something like that. And of course, we're going to get the same activity on the other side, right? So now it's going to come down to 0. It's going to come down to -1, 0, and then up to 1, 0, -1, 0, negative or +1. Okay, so the left side will of course be symmetric, and it will look something like this. Okay, so that's cosine of x. All right, now we want to look at 3 times the cosine of x. All right, so what happens there? Well, instead of a 1 at 0, I'm multiplying that value by 3, so I'm actually going to be up here. All right, and then 0 times 3 is still 0, but -1 times 3 is now going to make this a -3 down here. All right, so what's happening is that everything is being multiplied by 3 in this step. So we're going to get something like this. All right, so the right side of the graph will look something like this. All right, everything is being stretched by a factor of 3 here. All right, and then of course on the left side we'll get something similar. This is now down here. This is now up here. This is now down here. and this is now up here. Okay, so on the left side, we get the similar sort of stretching idea. All right, so something like this. Okay, so now of course in part B, they want to know what is the range of the function. Well, the range of cosine of x has range from -1 to 1. And of course, cosine, 3 times cosine rather, has range -3 to 3. Right, and of course that makes sense because all we've done is we've stretched everything by a factor of 3. So that's what of course the blue represents just regular cosine, and then the red is the 3 times cosine. Right, so that's sort of the difference, between those two graphs. Okay, now what we've just done is we've sort of looked at the amplitude. Right? So the amplitude of one of these trig functions is essentially take 1/2 of the average of your maximum and minimum values of the function, right? So for example, for cosine of x, since its range is -1 to 1, it has amplitude well, what's the difference of these highest and lowest values? It's 1 minus a -1, and then we're dividing that by 2. So this is a 2 over 2. So cosine of x has amplitude 1. Right? And of course, 3 cosine x has -3 to 3 as its range. And if you do 3 minus a -3 and divide it by 2, you get 6 over 2, which is 3. So it has amplitude 3. Right? And of course, another way you can think of this, and we'll see in a minute, is whatever number is in front of cosine, and again, if you don't see it, it's assumed to be a 1 there, that's essentially going to give you the amplitude. Okay? Okay, now let's see what happens to sine of x and -3 sine of x. Okay, so let's copy the graph again. So paste that. Okay, now we have our graph, and we want to look at, oops. Okay, so we want to look at y is equal to sine of x. I just changed my color of the graph there, that's okay. So we'll do this in black. So we'll do sine x in black, and then we'll look at y is equal to, I think it was -3 sine x, right? Yeah, -3 sine x. All right, well, what does sine look like? Well, let's fill it out in a similar manner as before. So we know that sine at 0 is 0. We know that sine at pi over 2 is 1, and at pi it's back to 0. 3 pi over 2 it's 0, and 2 pi it's 1. And then of course after that we repeat again. So this is up here, this is down here, and up here. So the right side of the graph will look something like this. And of course the left side will have the similar thing going on this side, so we're going to get something like this. Right, so we get this shape on the left side. All right, so that's our sine of x. Now for -3 sine of x, there's now two things going on. Right, because not only are we multiplying each value by a 3, we're also making it negative as well. Right, so all the zeros will stay put. If I multiply 0 by -3, they're not going to change. So all my 0 points are going to stay. But now all my y values that are 1, if I multiply 1 by -3, I'm going to get -3. So -3 will become down here, and we'll also get a -3 for this point here. And then on this side, we have a 1, so -3 there, 1, so -3 here. And of course, all my negative ones will become positive 3s. So then I have a 3 here, I have a 3 here, and then I have a 3 here, and a 3 here. Right, so now this graph will look something like this. Now it's going to be flipped upside down and also stretched by a factor of 3. All right, so something like that on the right side, and then on the left side, we'll get something like this. Okay, so we stretched our sine graph by a factor of 3, and we've also flipped it over the axis. All right, so now, of course, part B is to look at the range of -3 sine of x, and of course, we can see that that's -3 to 3 again, right? Because your lowest value is -3, your highest value is 3, and now your amplitude, again, is your highest value, which is 3, minus your lowest value, which is -3 over 2, so we get 6 over 2, which of course is 3 again, right? So maybe it's better to say that your amplitude is the absolute value of whatever number is in front of here, right? So it's your amplitude is always a positive number. Okay, now let's look at something else here. So now let's look at the next graph that we'll plot here. Okay, so let's plot my map here. Okay. Okay, so maybe that will keep it alone this time. Okay, so I want to look at cosine again. So we'll plot cosine in red. And then we also want to look at y is equal to 2 plus 0.3 cosine of x. Okay, so let's go ahead and do that. So we know that cosine, we already did that one, so we'll just plot that again real quick. All right, so at 0, we're at 1, pi over 2, 0, pi, we're at -1, 3 pi over 2, 0, and 2 pi, we're at 1 again, and then of course we repeat. So we get something like this. Whoops, there we go. So if we plot cosine, of course we'll get something like this. All right, and then of course on the left side, same thing happens, so we'll get something like this. Okay, so now when we plot 2 plus 0.3 cosine x, what we're doing is we're multiplying everything by 0.3, and then I'm adding 2 to it. So for example, 0.3 would be right about here, but then I would need to shift it up 2 units from there, right? So if I shift up 2 units, I would go up, for example, 1 unit would be here, 2 units would be here. All right, now if I multiply 0 by 2, or sorry, by 0.3, that's still 0, but then I need to shift it up 2 units. So that's going to put me up here. Right, and of course, if I multiply a -1 by 0.3, that's -0.3, and I shift that up by 2, that's a 1.7. So we'll get something like this. All right, and then of course we have a 0 again, so that's here. And then a 2 pi, we have 1, so that will become up here. Right, and of course this will repeat as well. So this is now something like this. All right, so now you sort of get this squashed version. Something like that. right? And of course, on this side, it will look the same, right? So here we get this, and 1.7 roughly, and then we're at 2, and then at 2.3, 2, 1.7, 2, and 2.3. So we get something like this. All right. So of course, this 0.3 made everything squash down, but the 2, of course, shifts everything up. So of course, if I take 0.3 and multiply it by my range of -1 to 1 and add 2 to it, my new range is going to be -0.3, comma 0.3 plus 2. So my new range, like we sort of said, was 1.7 to 2.3. Okay, so now, of course, to get the amplitude is going to be equal to highest value, 2.3, minus lowest value, 1.7, divided by 2. So this is a 0.6 over 2. So we get a 0.3. All right, and again, that's sort of your number in front of the cosine, so that would suggest that that would give us the amplitude. Okay, so that's what this graph will look like. Okay, now the next thing that we can adjust is what's called the period, right? Now the definition of the period is that it's a number p such that if I add it to the inside of my function, I essentially am going to get the same function that if I didn't add anything at all to it, right? So you'll notice that the standard period for each of these is 2 pi, all right? And sort of another way that you can think of this is that this is the longest, not the longest, it's the shortest time it takes for a graph to sort of return to the starting point before it repeats the pattern again. So you can see that here, the period is 2 pi because that's how long it takes to go a full cycle. Okay, so we can sort of summarize everything in the following way. All right, so in general, you can write the sine and cosine in sort of this way, right? So you have the number out front, which is a, and if you take its absolute value, like we said before, that would give you the amplitude of your function. Now, if you factor out your coefficient of your x term, if you take 2 pi and divide by that coefficient, that will give you what the period of the function is, right? And then just as we looked at in previous sections, c would give you the horizontal shift amount, right? And of course, if you have minus c, that indicates that you're moving to the right. If you have plus c, that indicates that you're moving to the left. And d is your vertical shift. If it's plus, that indicates you're moving up. And if it's negative, it indicates you're traveling down. So now this will work for both sine and cosine. And of course, tangent, the only thing that you would have to account for is that your period would now be pi over b, right? So it's one thing to keep in mind there. Okay, now we already sketched the graph of 3 plus cosine, and I guess we didn't do cosine of 2x. So let's go ahead and do that. So let's maybe just look at cosine of 2x since we already did 3 plus sine, 3 plus cosine of x. So let me paste my graph here and we'll look at sine of 2x. All right. Now I said that the sort of the number in front of the x is going to affect the period, but we're going to talk about sort of just go through it by hand, right? So let's look at, I'll make this 1, I'll make this -1. Let's look at y equals the cosine of 2x. All right. So what's going to happen here is that we have at 0, cosine of 2 times 0 is still cosine of 0. So that's still going to be a 1. But now what happens at pi over 2? Well, at pi over 2, I need to do 2 times cosine of pi over 2, which is cosine of pi. But what's cosine of pi? Cosine of pi is actually -1. So instead of going to 0, I'm going to go right to -1. right? And of course, where do you cross 0? You cross 0 at pi over 4 as your x value, because that's equivalent to cosine of pi over 2, right? So halfway in between here, of course, is when you're going to hit 0, right? So now you're seeing that every pi, you're making a full cycle, right? So you're going to get something like this, right? Every pi over 2, you're jumping from 1 to -1. So now your function is going to look something like this, right? So everything's sort of being squeezed a little bit tighter now. Right, and of course on the left side you would get something similar, right? So you would get something like this. Okay, a lot of zigzagging. So something like that, all right? And of course, to get the period, we can either say that if we're looking at cosine of 2x, my number in front of the x is a 2, so the period is 2 pi over 2, which is pi, right? 2 pi over that number. And you can also see that if you look at the graph, if I start at 1, the next time I get to 1 is here. And what's that distance of that interval? That distance is pi. So you can see that pi is your period that way as well. Okay. Now let's look at 7 times sine of 2 pi x. Okay, so let's put another graph here. And let's look at this one. Okay, so we want to plot 7 times sine of 2 pi x. Okay, now this one's kind of interesting, right? Because if you plug in if you plug in these x values here, you're going to get, for example, if I plug in pi over 2, you're going to get sine of pi squared, right? Which is maybe not something that's as easy to calculate. So what I'm going to actually do, and you'll see why, is I need to change my axis here. All right, so let's see. Now the question then becomes, well, what should I change my axis to? Well, let's take a look at our b term and we'll figure that out. Now, again, what's in front of the x? In this case, it's 2 pi. So the period is 2 pi over that, but that's also 2 pi. So in this case, your period is going to be 1. So that means for every distance of 1, you're going to start a new cycle, right? So that suggests that I should make this 1, this 1/2, this 1/4, and this 3/4. And if I do that, that should give me 1 complete period, right? And of course, I see that the amplitude is 7. So I'm going to make my high and my low points 7 and -7. All right. Now, for example, if you plug in 0, you get 7 times sine of 2 pi times 0. So that's sine of 0. So that's still 0. But if I plug in 1/4, taking 2 pi times 1/4, and if I multiply it, I get pi over 2 on the inside. So 7 times sine of pi over 2 is 7 times 1. So at 1/4, I'm up to 7. All right. And of course, when 1/2, I'm going to get sine of pi. So I'm at 0. At 3/4, I'll get sine of 3 pi over 2. So I'm at -7. And then back to 1 again. Right. And this is sort of how we can make the axis work for us, so that this is sort of something that we can plot that we're familiar with, right? And then of course this would be 1.5, 1 and, or sorry, 1 1/4, 1.5, 1 3/4, and 2. Right, so now this side of the graph will look something like this. right? And that gives us a good sort of idea. In general, it's nice to break your period into 4 equal spots, because then that gets you the 0, 1, 0, -1 sort of equivalent, right? And then, of course, the left side will look similar. On the left side, you would get something, right, like this. Let's see. So I guess I would need to do something like this, right? All right, and then that would be my 7 sine of 2 pi x, right? So now, of course, to answer the questions, the amplitude we can, of course, see is going to be 7, because that's a 7 minus a -7 over 2, so 14 over 2, which is 7. And we already said that the period was 2 pi divided by 2 pi, which, of course, is 1. All right, so that's our period of this one. Okay, I think we have, yeah, so we'll have 2 more examples, and then we'll wrap this video up. Okay, so the next one that we're going to look at is cosine of x minus pi over 3. All right, and I'll put cosine on here just so we can sort of see what's going on. So let me go ahead and paste my graph. Okay, so let's do cosine in red, and we'll do the cosine of x minus pi over 3. We'll do that in dark blue. All right, well, cosine, of course, I need to go from -1 to 1. So we have this for our cosine graph. Okay, so then we'll connect these. Something like this on the right side. And then, of course, on the left side, we'll get sort of the reflected version, which in the cosine case is actually the same thing. So we get this. Okay, so there's my cosine of x. Now for cosine of x minus pi over 3, what's happening here is, for example, if x is 0, I'm going to get y is equal to cosine of negative pi over 3, right? Because 0 minus pi over 3 is negative pi over 3. Well, that's like minus 60 degrees. And we know that at minus 60 degrees, we have that cosine is equal to a 1/2, right? So when x is 0, I'm actually going to be at 1/2. All right. And if I look at pi over 2, when x is pi over 2, all right, I'm going to get pi over 2 minus pi over 3, which would give me a cosine of negative pi over 6. Right? And that's a cosine of 30 degrees, and that's a square root of 3 over 2. Right? And cosine of square root of 3 is larger than 1/2. So we're going to get something like this. Right? And sort of just to cut to the chase here, the idea is that I'm taking my cosine, my original cosine graph, and this negative pi over 3 is a shift to the right by pi over 3. Right? So I need to take 1/3 of this distance here, right? So here is my distance of pi. So to go pi over 3, I need to take this graph and shift it this way by pi over 3, and that will give me my cosine graph. So I actually think I'm going to get something like this. Let's try this again. Okay, so I should get something. So pi over 3 will be a little bit less than that. So I should get something like this. All right, so everything is translated over by pi over 3. All right, so this distance here is pi over 3. All right, and then a similar thing on the other side. We'll get something like this. All right, so that's the idea. Okay, now you can see that the range, so part B is asking us for the range of cosine of x minus pi over 3 is still -1 to 1, right? Because we didn't change the y values for this. We just shifted everything over. All right, the amplitude is still 1, right? Because the difference between our highest and lowest y values is 2, and if I divide that by 2, I get 1. Let's see. So part D is we want to know the period. And of course, what number is in front of the x here? The number in front of the x is 1, so the period is 2 pi divided by 1, which is still 2 pi. And now the only difference is they want to know by what fraction of the period of cosine of x has the graph been shifted to the right. And of course, that has been shifted by pi over 3, right? Now, if you wanted to say this in terms of, I think they said, by what fraction of the period, right? So if the period is 2 pi, and I wanted to go to pi over 3, right, what would I need to multiply by? I would need to multiply by a 1 over 6, right? So we've taken this and we shifted it by 1/6 of its period, is essentially the idea. Okay, one last example. So we're going to look at two graphs again. And here the graphs will be a little bit more tricky. Okay, but we want to graph 5. And here we'll just do this sort of using the form that each function is in, right? So we want to graph y equals 5 times sine of x over 2, and also 5 times sine of x over 2 minus pi over 3. All right, so we'll sort of show the quick way to do this. So now if I want to look at the 5 times sine of x over 2, we know that this is going to have amplitude 5, right? So the distance between the highest and lowest point will be 10, because if we divide that by 2, we'll get 5. And if I look at the number in front of the x, I have a 1/2 in front of x. Let me keep my red here. So the period is 2 pi over 1/2, right? So the period would be 2 pi times the reciprocal, so times 2. So the period is actually 4 pi. All right. So now this is going to move slower, because now, again, if I plug in a 0, sine of 0 is still 0. If I plug in pi over 2, but then divide that by 4, I'm only at a square root of 2 over 2, and multiply that by 5, so you get 5 square root of 2 over 2. So it would actually take me until pi to get to 5 now, right? And it would take me to 2 pi to get back down to 0, take me to 3 pi to get to -5, and to 4 pi to get back to 0. Because now I have one full period. So this would look something like this. All right, now it's moving slower. We've cut its speed sort of in half. And of course, the left side would look similar. We would have something like this. All right, so something like this. All right, now you can see that the blue one is exactly the same, except we've shifted everything over by a pi over 3 again, right? So we're going to have that our new x value, right? So this is going to be a distance of pi over 3, right? So everything shifted over by pi over 3. So we're going to get something like this. All right, and then on the left side again, something similar. So we'll get something like this. All right, so those are our two graphs. Now we want to know what is the range of the function 5 times sine of x over 2 minus pi over 3. And of course, we're taking something that is between -1 and +1 and multiplying it by 5. So that range is -5 to 5. Right? Of course, what's the amplitude? It's the number that's sitting in front, so that's 5. What is the period? Well, we looked at the number in front of the x, which was 1/2, and we said that was 2 pi divided by 1/2, which is 4 pi. So that's our period. And again, the fraction of the period by which this one is shifted over, we said that it was shifted over by pi over 3. So as a fraction of the period, we need to do 4 pi. What would I need to multiply 4 pi by to get pi over 3? Right, so I guess we would need something like what is that, a 12 pi over 12? Not just pi over 12, just 1 over 12. And if I multiply 4 pi by 1 over 12, then we get pi over 3. All right, so it looks like we have shifted this by a 1/12 of the period. All right, so that concludes this video on transformation of trigonometric functions. I hope you enjoyed, and I will see you next time.